This is Mr. Beck Does Your Homework, homework number 15, question number 14. It says a bead slides without friction around a loop. Zoom, okay? The bead is released from a height of 11.6 meters from the bottom of the loop. The loop has a radius of 3 meters. The acceleration of gravity is 9.8. What is the speed at point A? Well, this is an example of conservation of energy. Here, what I have is I've got this point in the beginning, and I know that my total energy at that point is going to be my total mechanical energy at point A. So my total mechanical energy is made up of some potential energy plus some kinetic energy, possibly, and that's going to be my potential energy at A plus my kinetic energy at A. My potential energy at this point is going to be mgh. My kinetic energy at this point, well, it's released from a height and it's released from rest. It's released. So my kinetic energy is actually going to be 0. That's going to equal my potential energy at A, so it's going to have some mass and gravity and height there, and it's going to be moving with 1/2 mv squared. So there's my velocity at A, there's my height at A. So you might be smart and see that the mass cancels out, so that since I don't know the mass of the bead, I don't care about it, so I can get rid of the mass and all those. So what I'm left is gravity times my initial height equals gravity times the height at A plus 1/2 the velocity at A squared. Gravity is 9.8. The initial height for me is 11.6 meters equals gravity of 9.8 again times the height at A. What is the height at A? Well, if this is a 3-meter radius, then I know this is 3 and this is also 3. So this whole thing together becomes 6. So I'm going to get 6 meters plus 1/2 times the velocity at A squared. So I'm going to subtract this. So I get 9.8 times 11.6 minus 9.8 times 6 equals 1/2 times the velocity at A squared. Now you might notice that you could factor out a 9.8 here. You get 9.8 times 11.6 minus 6. Well, 11.6 minus 6 is going to actually be this difference in height from the top of the loop to the bottom of the loop. So really, I could have done mg delta h, the mass times gravity times the change in height, is going to be 1/2 mv squared. So that's a little trick if you get there. Otherwise, you got this number, you got a number, multiply by 2, square root it, and you will get yourself a velocity at A. Better be a positive number.